Now entered into Tony Tone's world. The Tony Tone's world.
All right. What is up, everybody? Welcome back to Tony Tone's world, TTW pod, the podcast, if you will. I am back with another episode. I brought back an old friend of mine. His name's Goose, aka Andy, aka Woody. I don't know. I was thinking about Toy Story. But no, I brought back my buddy Goose. We're going to talk some space, some outer space, some stellar stuff, if you will. No pun intended. What's up, dude? How you been?
Not much, man. I've been pretty good. I've been moving around a lot. I'm finally back in Florida. Feels good to be here. I'm sure it's going to get really hot during the summer, so, I'll have to deal with that when we get there. But, it's nice to be back.
Dude, I can't right now. Like, the winter here sucks. I mean, you lived in Iowa briefly, and you know how cold it gets in Iowa, but man, it's pretty cold here in Chicago right now.
Oh yeah, there's like a 5 or 6 day period where it didn't get above 0.
Yeah. It was like negative.
That was cold. Like, I've never experienced that before, but here just the other day, probably like 4 days ago, it was up to mid to upper 80s with a heat index in the lower 90s.
Oh, poor you.
Yeah, no, it's you say poor, but I'm telling you, that was too hot for this time of year.
Dude, I would pay money to go on vacation to go to a place that hot, We vacation where you live. That's crazy. That's so crazy. I don't know why you like the cold. I don't know how you enjoy it.
Maybe because I've lived in Florida my whole life. I don't know, but heat is not for me. It's not. I mean, I know I'm wearing like a hoodie right now, but that's because I keep it cold in here. So,
you have your AC on right now?
Oh yeah.
That's so fucking crazy, dude.
I have it on year round. It doesn't come off when I'm in Florida. It stays on year round.
Dude, right now it is 14 degrees here.
Yeah, it's right now it's a bit cooler here than it has been. We're in a little bit of a cold front. It's 60 degrees right now.
The fact that you even, dude, me and Nick were talking last week, our last pod, and he was complaining about a rainstorm that he was having. Do you mean just rain, Nick? Not a rainstorm? I mean, it's just
we had a little bit of rain the other day.
Oh my god!
That's actually what brought the cooler weather. It was kind of nice.
Yeah.
Yeah.
All right, so let's get into it, man. Last time we talked, dude, it was pre-COVID. Elon Musk was just bringing in Starlink, talking about it. Yeah. There was no, what's it, Neuralink, right? There was no, I don't know. It
started, but it was very, like, nobody had, it hadn't really been brought forward.
Yeah, Starlink, I'm not sure if it was there either, but...
I don't remember. I'm sure there were plans for it then, but yeah.
Dude,
by the way, have you seen the Starlink satellites in the sky?
I have not seen them in the sky. I've seen them at Costco.
Okay. Yeah. So if you catch the right time, and I'm sure there's tracks you can find online or something, but you go up in the sky, you'll just see like it looks like a star after a star just going across the sky. And it's really cool because it's like in a perfect line and they're just shooting across the sky nonstop. It's really cool, one after another.
Well, no wonder so many people think we have...
Oh yeah. So I mean, there's so many things that we put up there, and people immediately jump to something. They say that I don't know what that is, so that I know it's aliens. Well, you just said you don't know what it is. How do you know it's aliens? You know what I mean? I mean, that's just like I don't know.
Yeah,
I don't know. People just need to take a step back sometimes.
Dude, when there were, did you see any like the? It's so hard for me to say UAPs. It doesn't even sound right to me. I'm still so used to saying UFOs. So did you see any of those in the sky, like, several months ago? Do you remember like the whole thing on the news where they were seeing UFO or UAPs in the sky in like New Jersey on the East Coast and stuff?
I remember seeing some stuff on it. I honestly didn't really look too far into it. I'll tell you this, if aliens end up coming here, everyone's gonna know. Like, there's not gonna be a question. There's not gonna be some shaky video camera. No, we're gonna know. We're gonna know, and I think it's gonna be a lot bigger than just on some news article.
Yeah.
You're not gonna hide it. You're not gonna hide it from people.
Do you believe in that? Do you believe it? Just in general, do you believe in them?
In aliens?
Yeah.
Oh, I'm sure there's things out there somewhere. I mean, there's so many planets. There are so many possibilities of ways that life can start. And we're just talking about, like carbon-based life. There's other types there could be silicon-based life. There's a lot of different ways that life can start. And from everything that we've seen of life, which we only have one, data point, so it's not really good, but from everything that we've seen, it is really good at finding a way to survive. It is really good at starting and finding a way to survive. So to think of the, trillions of possibilities out there, to think that there's not one other one, I mean, there's no reason to think that.
Right.
It's better to assume that there is. Maybe not within our own galaxy, like maybe not intelligent life. I'm sure there's bacterial life in our own galaxy. Maybe not intelligent life. I still think there's a good shot that there is, but we haven't seen anything of it.
So I was doing a little bit of a deep dive on this asteroid has what 1% at one point it was 1% to hit the Earth.
Which one is it?
Oh, I knew you were gonna say some. It's like the most recent asteroid that they found.
Is it the 2024?
Yes, the 2024. Yes.
Yeah.
So this is what. All right, I'll tell you what I know, and then you can just debunk everything I say.
Yeah, go for it.
All right. So what I learned is the asteroid had a 1% chance of hitting the Earth, and now it's actually switched trajectories, and it has a 1% to hit the moon, and it's like 0.03% to hit the Earth. And then in addition to that, they took samples from the asteroid, and there's all the, god damn it, I'm gonna sound so stupid right now. All the parts that make up DNA were found on that. The building blocks for life were found on that asteroid. So they think that it could that could have been another example of like the asteroid, hitting another Earth, like somewhere far away.
So that's called panspermia. Have you ever heard of that?
Panspermia?
Yeah.
No.
It sounds made up. No, so that's the idea that life migrated from one location to another location, so from one planet to another via asteroid or something like that. So you take a planet maybe that had life on it, a massive asteroid just slams into it like it did when it created our moon here on Earth, and it sent pieces of the planet with microbial life out, and that eventually collides with another planet. And when that happens, you could spread life in that way. It's called panspermia.
Gotcha.
Yeah.
That's pretty cool.
Yep. Now, I will say about that asteroid, I haven't heard anything about them taking samples. I haven't looked extremely hard into it, though, so it's definitely possible. I wasn't aware of it for this one. But yeah, so when was the last time you looked up like the details on the percentages and stuff?
Like 3 days ago.
Hitting. Okay. So it's constantly fluctuating. And they're having trouble making up their minds on it. But the important things that we do know is that, yeah, so you're right, around that 1%. I think last I looked, it was at around a 1.5% chance to hit Earth, with it now being still more likely to hit Earth than the moon. Though it's still, I mean, we're not really 100% sure yet, right? We still need to do some more calculations. But they had given it a value of 3 on the Torino scale. Have you ever heard of the Torino scale?
No. I heard.
So the Torino scale is a scale given to asteroids to determine how hazardous an impact might be. So it takes into consideration how large the object is and the percentage at which it might hit. So they gave this asteroid a value of 3, which is actually the highest that I've ever seen in any asteroid. I've never seen one that's high, which basically states that it's an extremely close encounter with greater than a 1% chance of happening and could cause extreme localized destruction. That's what that means. So it's not like a world ender or anything like that. But the fact that it moved to a 3 meant that we needed to pay attention to it because we needed to know what's going to happen. When you're talking astronomical terms, when you say something has a 1% chance of happening, that's actually really high. Right? Now, you're still unlikely to happen, but normally when we're talking in astronomical terms, we're talking about like a 0.01% chance of happening, like the asteroid Apophis, which we can talk about that in a little bit if you want. But this one, yeah, pretty high chance for it to hit. Now, the size of this one is around, I don't know what, 50 to 90 meters, which is not massive. But if it were to hit, let's say it were to hit New York, right? Within 2 kilometers of the impact would immediately vaporize. Everybody just gone like that.
So like an atomic bomb.
Oh yeah, yeah. Do you know the I don't know how to pronounce it, the Tsar Bomba from Russia?
No.
Okay, it's like the biggest bomb that's ever been detonated on Earth. And that's about what this would be. It'd be about like that, strength-wise. So yeah, first 2 kilometers completely decimated, like it just vaporized, people dead instantly. You go out about 10 kilometers, there's basically like a massive fireball, and everything lights on fire almost instantly as well. You might still have some survivors, but anyone that does survive will be, they'll have severe burns. So really, really not good. And you'd be able to feel this 30 kilometers away from the impact site. It's going to be a massive shock wave that's going to shatter windows 30, maybe even 50 kilometers away. Like it's a big deal, but it's also not world ending. It's not going to destroy us. It's not going to, be like the one that killed the dinosaurs. That one was a couple hundred kilometers. This one's only 100 meters at most. And it's probably closer to 50 than 100.
And it breaks apart as soon as it starts hitting our atmosphere?
So it can. Yeah, it certainly can. So what happens when you take an object and you slam it into our atmosphere, you're going from space, which has no air, no molecules, into an atmosphere that does. And so it creates friction. That friction, when you have a very, very high velocity, creates a lot of heat, and it will start breaking apart that object. Most of the time, so if you look up into the sky and you see a shooting star, right, a meteor, that's a meteor that's coming into our atmosphere. What you're actually seeing is you're seeing that meteor burn up because of the atmosphere. It's shredding it apart. And when you see it finally disappear, it no longer exists because our atmosphere has completely, or destroyed itself in our atmosphere, I guess is the best way to say it. But yeah, this one would be big enough to come all the way and hit the ground, and it would be like it would hurt. It would, if it hit a populated area, it would kill a lot of people.
Is there is there such thing as like a? That was probably a dumb question again. Throughout this whole podcast is going to be a bunch of dumb questions.
There's no such thing as a dumb question and I'll tell you why too. The reason why there's no such thing as a dumb question is because that question means you're curious about something. That curiosity is what expands your own knowledge, and that's how you learn things. It is never a bad question.
So you're saying I'm a scientist?
Yes,
so,
pretty much, yeah.
So if an asteroid was shaped like a bullet, right, or like something like a pointy end, like a very large pointy end, to where it goes through our atmosphere, hits the Earth, could it pierce through the other side of the Earth if it had that much velocity to it, or no?
No, I
like,
don't
would we just have a big ass hole in the middle of our Earth?
Yeah, no, that wouldn't happen. So in order for something, and I could be wrong about this actually, I don't know. I'm pretty certain no though, because I think in order for something to have enough velocity to go through the Earth, it would actually make the Earth explode. It wouldn't happen. Like the Earth would actually completely break apart and no longer exist before a hole goes straight through it.
Damn.
I'm fairly certain that would happen first. So now, I guess technically, if you keep ramping up the speed, eventually it'll go through it like it's not there. Maybe that's possible, but I can't imagine anything in our universe naturally doing that. What
exactly is it like? Where's an asteroid form? Like, how is it? Is it just a bigger?
So when our star first started forming, there's a giant gas cloud, right, that started to condense, and that's what started to form the cloud. But there was a bunch of leftover gas, and that gas started circling around our star in a giant disk, right? So that's like a what do they call it?
Halo?
I don't know. It's just like the start of a solar system, right? That gas will slowly come together and form planets. Sometimes, though, what happens is as a planet starts to form, it gets kicked out by another body, right? That alters its orbital trajectory around the star. And when that happens, if it gets away from the dust, it doesn't get larger, or if other objects collide and break apart, you end up having all these pieces of leftover rocks that never formed into planets inside the solar system that are still orbiting around the star. And so that's where most of our asteroids come from. Now, you can have an asteroid coming in here from outside the solar system, but that is very rare. The reason why that's very rare is because there is so much space in between stars. If you take two galaxies and collide them together, which is going to happen, by the way, with the Milky Way and the Andromeda Galaxy in about like 2 billion years, when you do that, no star is going to collide. No star. You're going to have millions of stars coming together in this massive collision, and no two stars are going to collide because there's so much space in between each star. So it's unlikely for an object to come into our solar system. But it did actually happen. We actually had something pass by Earth that, based on its trajectory, did not originate in our own solar system. They called it Oumuamua. Have you heard of that?
I think I did hear this. Did it just recently happen like a couple months ago?
Very long, very skinny thing. It actually didn't look naturally made, and so a lot of people got very excited about it because like, oh, some alien did something. But we don't know. But from everything that we can tell, it's just some stray thing. Honestly, something probably collided. Something probably shattered. It sent this off on some weird trajectory that left its solar system that eventually came into ours, and we just happened to be lucky. Right? So, yeah.
Wow. So what were you saying about the Milky Way colliding in 2 billion years, a million years?
I think it's about 2 billion.
Jeez.
Yeah, I think it's 2 billion. I could be wrong on that. I think it's about 2 billion, though. So the Andromeda Galaxy is on a collision course with the Milky Way. We are heading towards each other rapidly.
Damn. And so what happens? So everybody just dies at that point?
Oh, no, we'll be long dead before that happens.
Well, we will, but what about the rest of the...
Well, so...
in 2 billion years.
Let me answer you this. If we don't figure out a way to get off planet, we will all be dead before then. Every human. And the reasoning for that is because our star... it's never consistent. It seems consistent in our lifetime because our lifetimes are only 100 years. So what's actually happening, though, is as our star is aging and it's burning more and more hydrogen, its luminosity is slowly increasing over time. And its temperature is also slowly increasing. So in about 1 billion years, the habitable zone of our star is going to slowly keep moving further and further out. And Earth will no longer be in that habitable zone. And maybe 1 billion, maybe 1.5 billion years or so, and Earth will, or potentially could turn into another Venus, where greenhouse gases start to take over and stuff. The temperature goes up, sulfur, all that kind of stuff, and that's definitely a possibility. And Mars could be more in a habitable zone then. But honestly, if the two galaxies were to collide and we were alive, basically we would just see stars in the sky in slightly different, areas over a very long period of time. A little bit more often, but that's it. You wouldn't really notice. You wouldn't notice anything else.
Wow, that's crazy.
Yeah. Yep.
Another thing I wanted to bring up too, so I had a couple topics, was the moon. I didn't realize that they have volcanoes.
Yeah, so I don't think they're active. I don't know much about that, honestly. If we wanted to talk volcanoes, I would know more about like Olympus Mons on Mars. I would know about the geysers on Enceladus. And
inform me.
I don't know if I'm saying
you
that
can tell me about those.
Yeah. Okay. So I guess they're more. I think it's Enceladus, and I don't know how to pronounce it, but that moon that's around Saturn, it has a bunch of geysers. They're not really volcanoes. I guess they're more like geysers where they shoot up water. But it's kind of interesting what happens because that water that's existing inside the moon itself is heated up because of both of Saturn, how close it is to Saturn, that's constantly pushing on the middle of that moon, that's constantly heating it up, and that gets shot out of these geysers. As soon as it leaves the moon, though, like as soon as it gets into the air, it immediately freezes because the temperatures are so cold. So you basically have like these giant ice geysers that are constantly just spewing out ice from this moon, but they're spewing out at such a rate that they're actually leaving the moon and helping form one of the rings around Saturn because of the amount of material that is constantly being shot out of the center of this moon. You also have these types of things occurring on Titan as well. I believe Titan has volcanoes, which is the moon also of Saturn that is full of methane. You have methane in all three. You have liquid methane, you have gas methane. You have an entire cycle, just like water here on Earth, but with methane, which they actually find very interesting, and they really want to send more stuff to Titan. I really wish that they would. I'd like to see what they could find there. Olympus Mons on Mars, so that's the largest volcano that we know of in our solar system. It dwarfs Mount Everest. Mount Everest has nothing on Olympus Mons. It is inactive though, so it's not like active. I don't think anything on Mars is active either.
That's crazy. Imagine having that big ass volcano on Earth. That's nuts.
Yeah, it's big. It is not small. That is for sure.
That's crazy.
Yeah.
What sort of like new space, breaking news in the past like couple of years that has come out since like COVID?
So there's been a lot of like different studies and stuff going on, especially with the James Webb Telescope. A lot of discoveries that have been going on with that. But one of the more interesting things, if you don't mind, if I slightly switch topics just a little bit.
Go for it. You go for it.
So Google had come out with this quantum computer chip called Willow. Have you heard of this?
I've heard of some, maybe. I think so, but maybe. I don't know.
Okay. So Willow was this quantum computer chip that it had some predecessors before. Google's been working on this for a long time now. But they had recently, and by recently I mean just like a few months ago, they had given this talk about Willow. And they were very excited about it because it was just breaking all expectations. So a little background on quantum computers. A normal computer, like a classical computer, supercomputer, whatever, it uses bits. Right. So bits is binary. It can be a 0 or it can be a 1. Right. And that's how it works. That's how computers work, like at a core level. And a qubit, which is short for quantum bit, is basically it has the ability to be a 1, a 0, or both simultaneously. And you can take these qubits and you can quantumly entangle them with other qubits in this computer. Which quantum entanglement, we're not going to get all into it, but basically what that means is that when you have two particles, in this case qubits, when you have them quantumly entangled, that means what you do to one, the reverse or the flip of that will happen on the other one instantaneous, no matter where in the universe you are. You could be 100,000 light years apart and it will still happen like that instantly.
Wow.
And so that's what we're using when we're building quantum computers. And it's way above my head. Like you need to talk to somebody else if you want to get specifics on that. I can give you like some basics like that, but it's one of the most amazing things in the world. What this allows us to do though, is it allows us to compute massive equations. So for instance, think about DNA, right? One of the things that we're trying to do is we're trying to do DNA folding so we can better understand DNA so that we can start to manipulate the DNA both on ourselves and patients that, like cancer, for instance. You can use CRISPRs and you can do all these kind of things, but we don't understand DNA well. And so we're trying to do all these computational things for it to understand it better, and our computers just can't do it. There's too much that has to be done, but these quantum computers go so much faster. And that's what made them so excited about this, because they'd kind of seen it in principle, but they hadn't had something as advanced as Willow yet. Willow was able to take a problem that a classical computer, the best supercomputer that you can find today on Earth, is not a quantum computer, would take millions of years, did it in like 5 seconds.
Damn.
Like it is fast. If you have a quantum computer that has 300 qubits, whatever it's pronounced, you can perform, You can perform more calculations in a second with 300 qubits than the number of atoms in a universe. You can simultaneously perform these calculations. Yeah, and that's what makes this so powerful. A normal computer today has to do one after the other, one at a time. Boom, 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 boom. This does all of them at the same time.
That's crazy.
Yeah, and so you can really, really, really go on this, right? I mean, you can do things that you just,
that almost reminds me of
have a hope of doing.
That almost reminds me of the cores in like a computer. Like how many cores you get, like 16, 18 or 8 or whatever, 30, 32 if you're lucky.
Yep.
Yeah, that's crazy. So they're using it now. Is that what they're transferred
So
over to?
that's quantum computers has been the big quantum computers is the next major breakthrough that's going to send us to an absolutely unknown era. I mean, it's there are so many more things than we're going to possibly have time to go in today that quantum computers could do for us. They're going to help us pass the singularity for AI. You know, and it's just there's so much stuff involved in it. But there's a story behind Willow that is very interesting because in December, suddenly Google shut the program down. They said out of nowhere too, like they had just given this press release. They were super excited about it. They were telling everybody this is the future. This is everything is working, exceeding our expectations. And then a week later, they shut it down and didn't give a word about it. They just completely shut it down. Of course, things started to come out a little bit. You know, they finally had to say something about it and all these kind of things. And the story behind it is just kind of crazy. So what they were saying was that the people that were working on it started to notice abnormalities within the data before it was shutting down, right? It started to have all of these different like weird things happening. And at first they're like, okay, this is just noise. You know, it doesn't really matter. But then they started to notice that it started to form patterns, very, very specific patterns that started to become more prevalent over time. And it happened more and more and more. And they didn't know why. Not only that, but the patterns that it was starting to create, which, by the way, they named them glyphs, they started to look like uniform and hieroglyphics and things like that. They even looked like symbols from the Mayans and the Aztecs, like really, really weird stuff. And they have no idea why it started making this. So what they decided to do is they brought a bunch of people together. This is all internally and everything. And they had a discussion about this, what in the world is going on? And some people believed that the signals were actually being generated by inadvertently overlapping the entangled qubits together and allowing it to basically find, I'm trying to remember everything that it was saying basically, but basically trying to find, or it was producing potentially mathematical structures that we have never seen before or even thought about before. Things that were happening that were just far beyond our own understanding. Mm-hmm. The next leading hypothesis, of course, was that the computer was becoming conscious, that it started to get into the realm of realizing that it was alive. And that scared a lot of people.
That's fucking
right?
Crazy.
That's the thing, right? That's the end of the world discussion there. So that did scare a lot of people, but you have to be careful with that, right? Because as humans, our brains are extremely good at finding patterns that aren't actually there, because our brains immediately try to understand something in front of us, even when it shouldn't. So we'll start to see patterns that don't there. Like think about mirages in the desert and things like that, right? You start to see things that aren't there. That's because your brain is it's creating this thing out of nothing. Mm-hmm. So that's one of the big things, but there's still more to it, right? So in the arguments about it being consciousness, what they were trying to do is they were trying to like compare it to our own brains, right? And the way that our brain kind of works, or at least what we think of as consciousness, even though nobody's been able to prove this is still very much a unknown field. But the best theory right now that I could find was that consciousness basically occurs from quantum processes happening within the microtubules within our brain. So the tubules are like microscopic it's like the microscopic internal framework of our brain or of our neurons. So that's where our neurons fire and they do all this kind of stuff. And they think that at a quantum level, consciousness is basically born if the system is right? Now, I don't know how to better explain that.
That was perfect. I totally understood what you were saying right there. Okay. That's
good,
crazy.
Because good. So what they noticed, though, was that how the qubits were working was very similar to this. It was very, very similar in what we've seen in our own brains, for instance. And not only ours, but all the different biological brains, right? So it's it's this resemblance of neural oscillations that had really gotten people interested, because it very much mimicked what we see not just in our brains, but in the brains of every living creature that has a brain, right? Very, very, maybe not every single one. I'm sure they didn't test them all, but you know what I mean, right?
Yeah, yeah.
So, they got very, very excited about this, but of course they didn't want to, you know, they didn't want to say it. You don't want to say this kind of thing, because if you start talking about this and start saying it's real and it is actually real, you might have a serious problem on your hands. Especially if it really is what you think it is. And if it's not, then you just look ridiculous, and then people are going to lose trust in what it is that you're saying. So it's almost like a lose-lose situation. But when this started happening, Google said, okay, well, this is happening. Let's see if we can figure out what's going on. Another thing that we needed to test was how hackable is a system like this. So they brought in a bunch of ethical hackers to hack the quantum computer to figure out the vulnerabilities. And this one guy, I forget what his name is, but he figured out how to do it, and it was very easy to hack it. And the reason why it was very, very easy to hack this computer was because a qubit that is both the 0, the 1, and could be either or, because of that, you can easily bypass it, which means you can bypass any encryption service that we've ever created for a computer, because of how a quantum computer works. It basically makes it completely pointless, right? Like it's like it's not even there. However, once they started hacking it, that's when the things got really interesting. This was right before they shut it down. What ended up happening was the quantum computer started to write its own code, its own encryption code, an encryption code that we have never seen, that no one has ever done before. And it looked eerily similar to an encryption code that was theorized as being a perfect encryption code. And it started to make this. And the idea was that the computer was protecting itself from people coming in from the outside. And
that's trippy.
It is, dude. It's actually, the whole story is crazy. Like I'm probably butchering the whole story. There's a lot to this. Like, and it's hard to find information. Like if you go online and try to find information on this, there's not much out there. Google's really put a cap on this, and they've done very well. But yeah, so the thought is that it started to protect itself, and they're pretty certain that's what was happening. They don't know why it was happening. It could just be, just some, thing that just happens, or maybe not. Maybe it decided that it wanted to protect itself because it saw that it was being attacked, and they basically freaked out. They said, nope, we don't know what it's doing anymore. It's doing something that looks more advanced than what we can do. We need to shut it down and kind of rethink some things here, because this is getting a little bit too complicated. And then they shut it down. That's
crazy. That sounds like that's like one good movie, actually.
Yeah, they need to make a movie out of it.
Dude, that'd be awesome.
That's exactly what Hollywood is, right? I mean, it is crazy. It sounds just like a Hollywood story. If you want, there's a video that I had ran across that does a really good job of explaining it. I will say the video that I found does have a slight narrative, so if you listen to it, just ignore the narrative of it and just listen to the facts and the things that people have been saying about it. I would say, if you want, I can give you that link. I don't know if you want to add it to that kind of stuff. It is a decent video, though. It does well with going into some details. So
that's so crazy. So as of right now, it's shut down.
Yeah, it's shut down. Yep.
No other company has a quantum computer.
So there are, but none of them were like this one. None of them has worked as well. So part of the problem with quantum computers is that you could have, first of all, you have to keep it almost at absolute zero. You can't have any temperature fluctuations, though. Any type of temperature fluctuation will introduce error into any calculation that it's performing. That error starts to propagate over time and become worse and worse and worse and worse. So you have to try to keep things at absolute zero. You can't even have vibrations. Like if someone were to tap like a table like that or something, then it would completely make it go haywire. It wouldn't be able to do anything. So most companies that have I don't remember the names of them, but some of the other companies that actually do have a quantum computer, they're stuck at trying to fix that. So we're still far from having an actual quantum computer work, but Google Google was definitely the furthest ahead, and they got into something that no one else has gotten into, and it scared them, and they shut the program down.
Shit, and they probably scrubbed the internet so people don't freak out.
I mean, I would
As
love
much
to see
as-
more. I've looked for more, and maybe there's more out now. I haven't checked today, but yeah, it's not easy to find stuff on it.
You got to use
Like
DuckDuckGo.
I even had trouble finding the videos where Google was actually talking like good about it. Like it's hard to find stuff.
You got to use a different browser. You got to go incognito.
Yeah, use Chrome.
don't
Gotta use
use.
Edge. You got to use the competition.
No, hell no. Don't. Maybe.
It'll be right there on the main screen. Google screws up right there.
How long do you think you could go? Knowing how I know that you play video games, how long do you think you could go working for Google and not trying to make a vibration?
Oh man, that would be very difficult. The thing is that it's okay. So the thing is that I feel like I would have to test it, right? Like if I'm in another room, if I just like tap the desk, is that enough?
Yeah.
Mess it up. I would slowly. I probably would. I don't know. I would hope that I wouldn't.
I honestly
No
would.
promises.
I would walk in and be the one to slam the door behind me.
Bam!
And get fired.
Damn it,
fired.
Tony!
That's so funny. That's crazy. Nah, that's a crazy story.
Yeah. No, it's really cool though. I mean, there really is a lot to it. I'll send you some videos and stuff on it. It's really cool. That definitely look into it, man. The thing is that nobody's talking about it. No news, like nobody's talking about it.
Yeah.
And that's just another thing to add to it, right? I mean, I think that's kind of weird that, even like the different articles that talk nonsense just to get people to view it, they're not even talking about it. Like it's kind of weird.
Dude, imagine playing.
I'm not into conspiracy theories or anything, but this one's weird. This one's actually pretty weird. It's worth looking into.
Well, now I got questions. Are the hackers, the ethical hackers, still alive, or did they mistakenly
Well, at least one of them
die?
At least one. So the one that figured out how to hack through it and how to hack through it so easily.
Don't tell me he's dead.
No, he's not.
Oh,
He's
okay.
not.
I'm about to
He's
say
not.
that's a conspiracy, brother.
Yeah. So I'll the one of the videos that I know about has him in it, and he talks about it a bit. I'll send that one to you so you can yeah.
Is he a young?
kinda get
Is he a young guy? I picture
Yeah.
him as.
Mhm.
That's crazy.
Yep.
That's crazy. Imagine the
he
security
looks-
clearance.
Yeah,
Jesus.
Oh yeah. When he found this out, he's in there like meeting with the CEO of Google and stuff, and like telling him he's got to be, I don't know, probably 15 younger than me. Like
That's
he's young,
crazy.
really, really young. I mean, looks can be deceiving, but he looks very young.
Yeah.
know.
Interesting. Anything else? Any other news thing you want to bring up? It's been
I
so
don't have
long.
anything specific. There's other. I mean, if we want to talk about volcanoes again, we could talk about Yellowstone. We could talk about the absolute devastation that would cause. Beetlejuice, if you want to talk about that, that's supposed to go. I mean, there's not too
Hold
much
on.
to talk about.
Not
It's
the
supposed to
movie,
go
right?
Supernova at some point. No, not the movie. No. Yeah, Willow, not the Disney movie Willow, not that one.
Okay. Hold on.
The Google Willow.
So what is Beetlejuice, and then
So Beetlejuice.
what's a supernova after that?
Okay, so Beetlejuice is the star that is kind of like the top corner of Orion in the sky, the constellation. Orion's belt, Orion, and all that. Like in the top corner is Beetlejuice. That star is really close to its end. It's already a red giant, and it is going to go supernova, which means it's going to explode, and it is going to be massive. Now, when I say, this is astronomical terms again. So when I say it's really close means any time in the next year or 100,000 years. So we might see it in our lifetime. Odds are we aren't. But in astronomical terms, that means it's basically almost dead.
So what happened?
Right.
What happens when it explodes?
So when it explodes, the supernova thing. Okay, so imagine a planetary nebula, right? A planetary nebula is when a small star like ours dies. It kind of just pushes out its outer materials, all that gas and stuff forms, whatever it is that it forms, and we look at it and we make a pattern out of it because again, our brains are great at making patterns like this. We just kind of invent things. But a supernova is much more violent. It is a super massive explosion. And that will actually send out shockwaves far enough to where if there's any other gas in surrounding regions, that can form new stars. So it's just a super massive explosion. Huge explosion. Yeah.
Will we see it? Like,
oh, we'd see it during the day.
Really?
Oh yeah. Yep. If that happens in our lifetime, you will clearly see it during the day.
Will there be a noise?
Even
like
though it is
boom?
so far away.
Will we hear anything?
No.
Is there sound?
Noise doesn't travel in space.
Yeah, that's okay. Hey,
yeah.
I'm getting there.
Light will, but noise will not.
Getting there.
Noise needs particles to travel.
All right. Now, what is a new nebula? What's a nebula?
So a planetary nebula. So when our star gets older, it will run out of hydrogen in its core, and it's going to start burning helium. When that happens, the star is going to start expanding. It's going to get really, really big. It's possible. I mean, it's going to swallow Mercury. It's going to swallow Venus. It might swallow Earth when it gets to this stage of its life. But eventually what happens is that the helium on the inside of the star that's burning also runs out. And when this happens, it sheds its outer shells, and all that gas and stuff basically just shoots away from the star, and it creates a planetary nebula. And what's left behind is a white dwarf, which is like basically a carbon ball that is white, much smaller than what our star is right now, very, very small. And that will continue to slowly fizzle out until it becomes a black dwarf, which takes a very long time. And by very long time, we in our entire universe do not have a single black dwarf yet, because not enough time has passed for a white dwarf to enter that stage.
That's crazy.
Yeah.
How do we know so much about space and we're just so
it's
young?
It's pretty crazy. So how do we know about space? And I'll give you an example of something that we've been able to figure out, right? So they've recently discovered a new planet that's not too far away they actually think have similar conditions on Earth in the atmosphere. So you could ask yourself, well, how in the world could they possibly know what the atmosphere is on a planet that is many, many light years away? You know what I mean? And we can't even tell what's at the bottom of our ocean. Well, the way that they do that is that you can take a star, you can see what kind of star it is, meaning what it's burning. It's going to be hydrogen, maybe a couple other things in there. But as a planet passes in front of that star, the light from the star will get absorbed by the atoms in the atmosphere. Now, we have figured out that every atom, like hydrogen, helium, oxygen, all those different things, every single one of those absorbs a certain wavelength of light. If light were to try to pass through it, it will absorb certain wavelengths. So when you look at the wavelengths of a star, when a planet passes in front of it, you're going to see absorption lines along the spectrum. This is called spectroscopy. And that absorption lines will tell you the atoms that were on the planet to absorb that sunlight. And you can determine what the atmosphere is on that planet because of what's blocking certain wavelengths from that star.
So it's
which is really cool.
It's
but
all
yes, that's how we would do that.
It's all one big mathematical equation, essentially?
Yeah, pretty much, yep. Math is like the absolute. I mean, that's what we use to explain everything. Math is our, that's one of the greatest tools that we have. And there's certain things in mathematics that, we believe are universal, like pi. Sure, we assign it a value, 3.1415, whatever it is, but the concept of pi, any intelligent species out there that is able to get off planet will understand the concept of pi. There's no way they can't understand it. Just like they're going to understand certain concepts of chemistry. You have to. Because the only way to get off planet is you have to exceed escape velocity. To exceed escape velocity, you have to have certain understandings about the size of your planet. You have to understand, the atmosphere, the atmospheric composition. You have to figure out what fuel you'll need to actually burn to achieve this speed based off of whatever weight it is you're taking off planet. There are certain things that you have to know to kind of get to certain levels, right? And in mathematics, we think that most of that stuff exists, like pi. or like E and things like that. And there's still a whole bunch of things about math that we don't understand. That's another reason why they're very excited about Google's Willow, because it is possible that the qubits were actually taking mathematical concepts from other dimensions and putting them visibly for us to see. And they're not sure that wasn't actually happening. That's very possible because quantum quantumly entangled particles are thought to be able to access these dimensions. I don't have a better way to say it. That's not really the right way to say it, but I don't really have a better way to say it. So
it's all right. Makes sense to me.
It all makes perfect sense. You know?
All perfect sense. What are your thoughts on the astronauts being stuck in space? It's crazy they're still there.
So, yeah, I mean, I will say that's one of the training exercises that they'll go through. What happens if they're stuck, right?
For this long?
So how long has it been actually?
Let me do a quick Google.
You can eyeball it. You don't have to give me.
I thought it was since June of last year, but maybe I'm wrong.
So that is longer than they would like. I think that's over. What is it, like 6 months? Is like they don't really want you up there for longer than that. But we've had humans in space for longer than that. We actually did an experiment that not many people know about with a twin. It was these twins that were brilliant in astrophysics and all that kind of stuff, and they decided that they were going to send one of those twins into space for like over a year or something like that, so that they would have the other twin on Earth and they could compare the differences between the two when he got back to see how space actually affected the body and the mind and everything.
Mm-hmm.
That was really cool.
I briefly saw a video saying that astronauts are known to get, like, I don't even, like, what happens when the astronauts return back to Earth? Or is their body functioning correctly? Or is it, I saw in a video that basically astronauts get cancer or prone to cancer after coming back from space.
I would say it's, you have a greater chance of getting cancer, but not because you're coming back, because you don't have the atmosphere to protect you when you're in space. Right? Our atmosphere is constantly protecting us from the radiation from our star. Our star is constantly emitting radiation, and our magnetosphere is protecting us from that. The sphere that, is basically circling our planet caused by our core, it protects us from that. Actually, auroras, like the northern lights, that happens because of electrically charged particles that are slamming into our planet, but our magnetosphere is protecting us, and so it travels along those lines and goes up to the poles, which is the north and the south pole. And what happens is that the stronger those electrical charged particles are, the further, like, south, if you're coming from the North Pole, or north if you're coming from the south, that the auroras will be, because those are just electrically charged particles. So think about it. When you're in space and you don't have that protection, those can just hit you. Yeah. Radiation can just hit you. And so that will increase your chances of getting cancer.
Gotcha.
Doesn't guarantee you're going to get cancer. Coming back to Earth doesn't guarantee you're going to get cancer. It's just being there in general increases your odds of getting cancer.
Gotcha. And so I looked it up. They have been there since mid-June of last year. Okay. So like even like the just daily functions of being there and stuck in that, I'm sure, a tight space, the sewage system. I mean, what happens when they go to the bathroom? It doesn't just go in, we just don't make more space junk, do we? Yeah, I'm sure there's like a little bin for it. I'm sure that's overflowing. Do they have enough food? Some water?
Just throw it out the window.
What are they doing?
Let it fall back to Earth. It's fine.
Our atmosphere will kill it.
I mean, they might actually. I don't know what they do with that. They might dump it out there. I really don't know.
Is there a lot of space?
I could tell you it would burn up in the atmosphere. It wouldn't actually hit the planet. If it fell into the atmosphere, it'd burn up.
Imagine if you're the one astronaut that takes a shit that has greater withstand to pass through the atmosphere.
Higher density. Yeah, no.
Oh, that's so funny.
I'll tell you what's scary though, man. Like, being in space. So that wouldn't actually bother me as much. The things that would bother me the most, or the thing that would bother me the most, is having to do a spacewalk. I'd still do it. Don't get me wrong. I'd still do it. But a spacewalk is dangerous. If you become untethered, you're done. They're not going to get you. Like, as soon as you start floating away, if you're untethered, that's it. There's nothing they can do. They will have to slowly watch you float away as you slowly watch them float away. And you're given
crazy.
2 choices at this point. You have 2 choices. The first choice is you can wait about an hour until you run out of oxygen, and then you can suffocate, which is the preferred method. Because what happens is, have you ever, like after exercising, you sit for a little bit, maybe didn't drink enough water, then you stand up quickly and you get that head rush?
Yeah. Yeah.
It'll feel, I think, pretty similar to that when you start running out of that oxygen and stuff. You get real lightheaded and you pass out and die, which is not the worst way to go. It's still not great because you're going to be sitting there thinking about it for an hour, which is horrible.
Right.
But the other option is you could open up your spacesuit, which is bad. Okay. The reason why this is bad is in the first 10 seconds, a couple things are going to happen. The first thing is that if you have any air in your lungs, it is going to expand. So if you were to ever be in a situation where you are in space and you lift up that visor, immediately let out all your air or your lungs are going to pop. And you're going to feel it because you're still going to be alive. They will, So yeah, immediately exhale. Just
That's
exhale
crazy.
everything. Yep. The next thing that happens, this is still within the 10 seconds, all of your bodily fluids will start to boil. This includes your saliva. Yes, your
Holy
saliva,
shit.
your blood, all of it. It's going to start to boil. And it will keep boiling for a while, but within the first 10 seconds, that's when it's going to start boiling. At about 15 seconds, that's when your brain is no longer going to be able to take it and you're going to pass out because lack of oxygen to the brain, and the whole craziness of what's actually happening, you're going to pass out and you're not going to wake up again unless someone rescues you within the first 30 seconds of you lifting up your visor. Because what'll end up happening after that 30 seconds is your skin will start to freeze. It's funny, right? Because like sorry, my camera keeps getting blurry there. But you'd think that, okay, well, if my blood is boiling, then why is my skin freezing? Because your skin will start to freeze at the same time that your blood is boiling. And it gets really, really, really quickly, you'll get to the point where you're beyond help. But the reason why we know that you can come back from this is because we actually had an accident in a vacuum chamber here on Earth when, I think in the 60s or something, when we were first like practicing for spacewalks and things like that. And somebody accidentally didn't have their suit pressurized properly, and so they got that zero pressure and all that kind of stuff. And all this stuff started happening to him. He said he could feel the saliva in his mouth boil before he passed out. He passed out after like 12 or 13 seconds or something like that. Yeah, crazy. They were able to get to him within 30 seconds, and they were able to bring him back. But
and he lived?
Yeah. Mm-hmm. Wow. I don't know for how long, but yes, he lived. Yep.
That's crazy. Have we ever had an accident in space?
Not on a spacewalk. The only people that we know of that have died in space have been basically on shuttles. We had 2 problems here in the U.S., Challenger and I think the Columbus, that exploded. Those 2 problems, and then there was another problem for Russia. I think there were 4 people on this team, and they were actually leaving the space station, and they went into their their cabin to go back to Earth, and the seal didn't properly seal when they were right before they took off, and that it depressurized, and they all died before they even got back to Earth. And I don't even think we knew it until it landed on Earth and saw that they were all dead.
Damn.
So that's happened. Yep. If anything else has happened, then that's never come out. So it is possible that others have died. Today, it'd be very unlikely for it not to come out. Back 40, 50 years ago, it's possible that happened. There's actually a story about Russia and an astronaut that they sent into space, the very first one that they sent into space on a one-way trip just to see what would happen. And there's like a horror story with that and stuff, but nobody knows if that's real or not. So because we're not sure, it's better to just say it's not real because we don't know. Yeah.
How would you become untethered? I would assume they would have it locked down, bolted to the.
All right. Well, mistakes happen. We've never made that mistake. So, but mistakes. I was actually just watching a video the other day. It was a guy on a bungee cord, and they were just about to like unhook him, and they accidentally unhooked the safety harness.
Oh
Not
shit.
the bungee cord to make him go, but the safety harness. And people started screaming, people freaking out. The guy's like over the cliff, like hanging there, like
Holy
freaking.
shit.
Yeah, scary, scary, scary. They finally got him. They finally got him, hooked back up and everything. But that was like, if that was me, oh my god, I'd probably died right there.
Yeah.
I've been dead right there. So, but no. So we've never had a problem like that on a spacewalk, which is really good because that's a scary thing.
For sure. Would you go to space? They're talking about.
Absolutely.
Yeah, I think.
Yeah, I go tomorrow.
That's crazy. I don't know if I could go to space. That'd be
I would
nuts.
do it. I'd do it. I'm too curious, man. I'd have to. I'd have to.
Yeah.
I have to see it.
You have to go through some intense training to be an to go actually go to space.
Months and months.
That's crazy.
The thing too is that the people that select for this, they go through that training. That doesn't guarantee you get to go. You have to go through all this training, and you might not go.
Damn.
Because they only need a couple of people. They'll always have backups ready to go just in case.
Mm-hmm.
And the majority of people going through the training are backups.
Wow.
Yep. So, just because you get to go to the training thing, you better still be on your A game the whole time because everybody else is still gunning for a position.
You can't be 5 minutes late to that meeting.
No. You got to show up on time. You got to be early, stay late, put your time in, do the whole thing.
Yeah, that's crazy.
Yeah.
Oh, so do you think why is it so hard for them to bring back the astronauts when we have Elon bringing his back on a daily basis?
Oh, honestly, I don't. Are they from Russia? Is it Russian?
No, they're U.S. They're U.S. citizens.
They're U.S. Okay.
Yeah.
Honestly, I have no idea. I have not looked much into it. I heard about it in passing, but I didn't look much into it. And the reason why is because this could be some small little thing, and the astronauts could be like, not a big deal, because they do train for this. They train for this exact scenario. This is one of the ones. Well, what if you are supposed to go up there for 3 months, but something happens and you're there for 12 months? You need to be prepared for that. And they are. They get trained on that exact situation. When they go up there, they know that they might be stuck up there for a long time. They hope not. Hope for the best, but prepare for the worst. So they're probably perfectly fine. I'm sure they want to come back and they're trying to figure it out. But one thing that they're not going to do is they're not going to rush into it. They're going to take their time. They're going to make sure that they get things done right, and they're going to try their best to get them back safely.
Do you have the same curiosity that you have for space for underwater?
No, I'm actually terrified of underwater.
Really?
Oh, yeah.
Why? Anything specific?
Because, man, there are some crazy things in that ocean. Like, now I'm not talking about like a giant pool. I'm not afraid of deep water. I'm afraid of the ocean. Like, there's a difference. I'm afraid of massive creatures underwater that I can't see. Jellyfish. I'm afraid of jellyfish. That is one of my fears, man. Jellyfish. Yeah. I can't take it. But no, I don't. No. I'm more afraid of the ocean. Well, like that expedition that went down that imploded. You know what I'm talking about?
Yeah, submarine. Yeah.
Oh yeah. So have you heard about the details about the implosion?
That they instantly died, didn't they? Like within like a matter of seconds.
It wasn't exactly instantly, but close enough. And I'll tell you how close of instantly it was. So the human eye and the human brain are capable of only noticing something once every 10 milliseconds at best, right? Or somewhere right around that number.
So it's like
if anything happens faster than that, we can't even perceive it. Like if something were to go by you, faster than that, you would never know it was there. You could not comprehend it. You couldn't see it. You couldn't think about it. It wouldn't happen. This imploded in less than 1 millisecond.
Damn.
I mean, yeah, they were probably sitting in there. They probably heard some creaking and then they didn't exist.
Wow.
Yep.
That sucks.
So not exactly instant, but for the most part, instant.
Would you go on a submarine, like a military grade submarine? No.
Well, maybe military. Okay, so that depends. If I was obviously, if I had to do it for service, I would do it for service. If I was doing it just to kind of see what it was like, that too, I would not want to do it as like a vacation because I would probably be nervous the entire time.
Damn. So you feel more comfortable going in outer space where
Yes.
we don't know. I don't know. That's crazy. I think I would go with the submarine.
Space, from here to space is only 1 atmosphere difference. From here to the bottom of the ocean, 300 atmospheres. 300 times the pressure change. It is much harder for us to navigate that than to navigate pressure in space. It's still difficult about space because you have to consider orbital mechanics.
Yeah.
Whenever you're in space, you're never going in a straight line when you go into space. Like if you go to the moon, you're not going straight to the moon. You are going in an orbit that happens to coincide with the moon. So in order to
So you're going in one big circle until it reaches your.
Yes. Yep. So think about this. Think about the space station, right? That's going around our planet. It's going around constantly, right? In an orbit around our planet. If you wanted to go from the space station to the moon, you have to increase your velocity so that your orbit becomes larger until your orbit matches that of the moon, and then you can get onto the moon. This happens with every planet. If you want to go to Mars, you have to increase your velocity from an orbit of Earth in order to expand that orbit out to not only match Mars, but you also have to have that center be the sun because that's what Mars is orbiting. And so in order to get from Earth to Mars, you can't just go in a straight line. You have to orbit your way out there and hook up with it. That's the only way to get to it. And that it works like that with every planet, which is also why it's not so easy to send like a probe to a planet. You can't just do that. It has to be timed right, or you can't do it. At least with our technology, you can't do it. Mm-hmm. So that's why right now we don't have any huge plans for our outer planets because it's not a good time for us. We've already passed that time, which is why we sent out Voyager when we did all those years ago because it passed by a lot of them. Gotcha.
That's crazy. I didn't know that. So you're saying from here to space is 1 atmosphere in the ocean. The deepest part of the ocean is how many? 300?
300. I don't know the exact number, but yeah, it's a lot more. Yeah.
That's
crazy.
Think
about it, right? So on the surface of Earth or any planet really, the amount of pressure you feel is all about how much atmosphere is above your head. Right? Mm-hmm. How much is pushing down on you? That's what pressure is. In space, there's nothing pushing down on you, so there's no atmosphere. So you go from 1 on Earth to 0 in space. If you go underwater, you're adding water, which is much heavier than air, on top of being above you with that same air. And so the deeper and deeper you go, the more and more that pressure stacks. And you get a higher and higher atmospheric pressure.
Dude, you should start your own podcast, like a daily videos or something like that on TikTok or something.
I'm not like a full expert though.
No, but you explain it very well to where I understand. And if I understand it, then I'm sure plenty of other people can understand it.
Well, I did start those 5-minute insights on YouTube. That was years ago too. That was actually around the time we did this podcast last. Maybe I'll start doing those again or something.
There you go. All right. Well, dude, I appreciate you coming on. It was a long time coming. I know I'll have you on again. It's always a good flow, good conversation. But yeah, until next time, dude. Appreciate it. Have a good one.
Yeah, just whenever you want to do it again, I'll have a lot more time now, so we can always do more if that's what you want. So just let me know.
Before we go, 2 things.
Mm-hmm.
I know I'm talking to the right person because this guy has a galaxy on it as his bedspread. And
yeah, I do. I don't know if you can see it.
Yep, there he goes. There he goes. Yeah. And then 2, the computer behind your background reminds me of it. Keeps reminding me of the quantum computer.
Yeah, like the ethical hacker, right? This gives me hacker vibes. So
Yeah.
It's kind of fitting, right?
Yeah. All right, dude. Well, again, appreciate you coming on. Till next time. Peace.
Yep. See it.
The Tony Tones world.